Imagine standing on a tiny moon, and above you fills the sky, an enormous ringed planet stretching from horizon to horizon. Stay with me, because in the next minutes I'll take you there step by step, and you'll never see the night sky the same way again. By the end of this video, you'll know how big those rings really look from the surface, why they shine even at night, and what it would feel like to watch their shadows crawl over your world every single day. Let's start with where you're standing. Look up. The planet doesn't look like a distant dot. It fills a huge slice of the sky, maybe 20 times wider than our moon looks from Earth. You can see colored bands swirling across it, and a thin, dark line where its rings cut across the disk. Those rings? From this moon, they are not a little loop. They're a massive bridge of light, stretching from one horizon to the other. Imagine an endless glowing river drawn right across the sky, curving over your head in a perfect arc. Each ring is made of countless chunks of ice and rock, but from here they blend into smooth, bright bands. No individual rocks, just clean layers of pale gold, white, and blue like strokes of paint. At night, they still shine. How? They glow because they reflect the light of the star and the planet itself. Even when the sun is low, that giant planet bounces light back onto the rings and down onto you. It's like living under a vast, permanent twilight ceiling. During the day, shadows on this moon are strange. The rings act like a huge striped lampshade. As the moon moves in its orbit, the rings' shadows sweep across the ground in giant bands, turning the landscape from bright to dim in slow waves. Sometimes, the planet itself gets in the way of the light. Then you'd see a colossal eclipse. The star slowly disappears behind the planet, and the sky deepens to rich purple, while the rings glow like a ghostly halo around a huge black disk. Let's talk scale. If our moon were swapped with a moon orbiting a giant ringed planet like Saturn, that planet might appear hundreds of thousands of kilometers away, yet cover a massive portion of the sky. It would feel close, but it's still far. Walking across this moon, the planet always stays in almost the same part of the sky, barely moving during one day. It doesn't rise and set like our moon usually does. It just slowly tilts and shifts, like a painting that's alive. At the poles of this moon, the rings might slice straight across the sky as a vertical band, but near the equator they lean at an angle, like a tilted staircase of light. Where you stand completely changes how the rings paint the heavens. Now imagine a slow, silent meteor shower made of ring dust. Tiny particles drift down through the thin sky, sparkling as they catch the light from the rings above. You reach out your hand, and of course, in this thought experiment, you're safe. This world isn't just beautiful, it's scientifically wild. Tides from the planet stretch and squeeze the moon, creating underground oceans or cracking the surface. Those same forces help keep the rings in shape, like a cosmic sculptor. The rings themselves stay in a thin, flat disk because of gravity and countless gentle collisions. Every piece pulls on every other piece, settling into a plane. From your moon, that flatness is what makes them look like a sharp, bright ribbon. Sometimes your moon might pass through the shadow of the rings. The sky darkens suddenly, not from a cloud but from a giant stripe of darkness overhead. For a while the rings vanish, then slowly reappear glowing at the edges. If other moons share this planet, you'd see them too. Little bright dots sliding back and forth in front of the rings. Some would zip quickly, some crawl slowly, each one tracing a glowing path across the striped background. On some nights, the star sets, but the planet still glows. Clouds and storms on its surface scatter light, bathing your moon in soft-colored hues, maybe pale orange, maybe bluish. You'd have planet light instead of just moonlight. Let's freeze time for a second and zoom out in your mind. You, tiny, standing on this moon, the moon circling the giant planet, the planet circling a distant star. All of it just one scene in a vast galaxy packed with other ringed worlds. Back on the ground, you lie on your back and watch. Over hours, the planet slowly turns, new bands rotating into view, storms shifting position. The rings seem steady, but if you're patient, you notice faint changes in brightness patterns. You might wonder, could life evolve here, under this constant cosmic show? Maybe creatures that navigate by ring shadows that time their growth to eclipses. We don't know, but the physics of such a sky are absolutely real. Scientists use math and spacecraft data to simulate exactly these views. We plug in the size of the rings, distance to the moon, tilt of the planet, and out comes a sky map. Where the planet sits, how bright it is, when eclipses happen. From Earth, we see Saturn's rings nearly edge-on sometimes. But imagine being on a moon when the rings are edge-on for you. Instead of a broad band, they shrink into a thin glowing line, like a cut through the sky, sharp and delicate. Now flip it. When the rings are most tilted, the sky explodes with detail, layer after layer stacked above you, like shelves of light. The horizon glows where the rings disappear into the distance, giving you a permanent false sunrise. Even the seasons here would be tied to the rings and the planet's tilt. Over years, the angle of sunlight on the rings changes, making them brighter or dimmer. Your calendar wouldn't be months and years, but ring angles and eclipse cycles. So what would you remember most after a lifetime on this moon? Probably the feeling that the sky is not empty. It's structured, layered. The universe isn't just up there, it's visibly wrapped around your world in shining hoops. Keep that image in your mind. A quiet moon, a towering planet, and rings like a cosmic highway overhead. Next time you look at a picture of Saturn, remember, on some moons out there, this is the everyday sky. Not science fiction, just physics. If you enjoyed this trip, imagine what other skies are waiting. Double suns, glowing nebulae, worlds with no nights at all. Hit subscribe so you don't miss our next journey, where we'll visit a planet locked forever to its star.